MietY Secretary inaugurates India's first Nano Electronics Roadshow in IISC Bengaluru. 7 colleges showcase 100+ IPs and 50+ technologies *. 4 MoUs signed between the academia and the industry at Nano Electronics Roadshow. Bengaluru, 27th March 2025. The Nanotechnology Initiatives Division of the Ministry of Electronics and Information Technology, MeitY, in partnership with IISC Bengaluru, IIT Bombay, IIT Madras, IIT Delhi, IIT Kharagpur, and IIT Guwahati, successfully hosted India's first Nano Electronics Roadshow on 27 March 2025 at the National Science Seminar Complex, IISC Bengaluru. The roadshow was inaugurated by Shri S Krishnan, Secretary, MeitY, along with Shri Abhishek Singh, Addl. Secretary, MeitY, Utpal Shah, SVP, Tata Electronics, Anand Ramamoorthy, Micron, Govindan Rangarajan, Director, IISC, and Juzer Vasi, IIT Bombay. Other prominent dignitaries included Dr. V. Narayanan, Chair, ISRO, Rangesh Raghavan, India Head, Lam Research, V. Ramagopal Rao, VC, BITS Pilani, Dr. Shivkumar Kalyanaraman, CEO, Anusandhan National Research Foundation, among others. This marked a significant milestone in India's vision of a self-reliant semiconductor ecosystem. The roadshow showcased 100+ intellectual properties, IPs, 50+ groundbreaking technologies, and the innovation of 35+ promising startups, all backed by 6 state-of-the-art nanoelectronics centers across the country. Taking forward Hobbieli Prime Minister Shri Narendra Modi's clarion call for Atmanirbhar Bharat, the conference highlighted India's technological leadership in the electronics and semiconductor domain, driven by cutting-edge research and innovation at nano centers established by MeitY within the IISC and IIT ecosystem. The roadshow served as a platform for 700+ industry leaders, policymakers, and academics to explore areas of collaboration around strategies for strengthening India's nanoelectronics ecosystem. Addressing the gathering, Shri S Krishnan, Secretary, MeitY underscored the critical role of MeitY's nano centers in fostering innovation and talent development to build a semiconductor-ready workforce of 85,000 professionals. He emphasized that the event represents a significant initiative by MeitY and the Government of India, symbolizing convergence and fostering industry-academia collaboration, with the government playing a catalytic role in shaping India's technological and industrial future. A key focus of the ministry is aligning various efforts to advance the India Semiconductor Mission, one of the world's most extensive subsidy and grant programs. With nearly 70 to 75% of investments in major semiconductor facilities,
cost competitiveness will be one of the biggest selling point of India as well. And then environmental sustainability. We are starting our fab with 100% green power, close to 100% water recycling. These are things that are very, very hard to achieve in a country like Taiwan or even a country like US. So India stands to gain from environmental leadership and promote that aspect with the customers. Customers are very keen to actually buy their products that are produced in an environmentally friendly region. So now let me segue into what are we doing in Tata Electronics. We started the company in 2020, in May of 2020. It's been little over 4 years, going to be 5 years soon. There are 4 lines of businesses that we have started the company with, starting from design services, where we support our customers for any type of design need they have for their product, to manufacturing the chips, which is our foundry business, to packaging those chips, which is our OSAT business, to system level manufacturing, where we manufacture components and put the entire systems together, which is our EMS line of business. I am proud to say that we have, in the last 4+ years, we've made tremendous progress. We now have 7 sites, manufacturing sites, Four of them are operational in terms of manufacturing.
This was happening 25 years back in 100 plus colleges and clean rooms in US. And you know, while I'm extremely proud and happy with the nano centers that we have, it's quite obvious that that scale is not enough for the country. We absolutely have to scale up. We have to have a lot more of R&D clean rooms. We absolutely have to redefine how we do things here in the country. And I think what often happens is we have a large base of good ideas, wonderful ideas. You know, we are talking about compound semiconductors, photonics, the march towards quantum at some point of time. It's important that together we try to converge those ideas into a narrow prism of execution-focused elements, so that we're not spread thin. We focus on exactly what India is generally good at, and it's a debatable topic. But I believe there is also some need to restructure. We have a great architecture of incentives and grants through PLI and ISM. We have to get, I'm sure, I'm very hopeful in ISM 2.0, we'll see a lot more of R&D architecture grants, which will benefit all of us to grow the ecosystem further. And there are many parts of R&D like product engineering, test, probe, that are very foundational to making manufacturing happen at the scale the government wants us to happen. I think this is, whenever I meet Mr. Krishnan and our honorable ministers in MeitY, nothing new here. I just feel like
500,000 square feet clean room testing facility in Gujarat. So, join me in welcoming Mr. Anand Ramamoorthy, ladies and gentlemen.
To bring it into the country at scale, and we have failed. Therefore, this is the time to actually attempt and make sure that we succeed to bring it. And therefore, it will be historic when actually the first chip comes out of Micron's facility later this year. That is the importance. Now we can go to the very small, most advanced we are coming together, is illustrating that more than anything else. Of course, you know, when we are spending so much money, we are often asked questions saying, are you doing the right thing? Are you investing in the right technology? Is this the right stage? I've been asked this several times. The rest of the world is moving to 2 nanometers and 1 nanometers, and you guys are stuck at 28 nanometers and 40 nanometers and 60 nanometers. How does this make sense as policy? I think it's carefully considered policy, and it is worth repeating on this occasion, that we have to strike a balance. We are not a very rich country yet. We are already the 5th largest economy, but on a per capita basis, we are not a rich country. Therefore, there are limits of the fiscal capacity of the government as to what you can afford. And what we can afford is what we need to attempt to do. And so the roadmap on this is very clear, and that again is significant